computer. And I think we're recording. All right. So today we're gonna talk about finished chapter 1 with the beer song, which I did like a lame old meme about holding beers, and that I put on the Discord on Twitter. And first of all, let me put it this way. Actually, I'm gonna review it. Yeah, I'm gonna review it. I was thinking of asking, hey, do we want to review this? Was clear enough or not? But I'm just gonna review a couple of points on the beer bottles thing. So the first thing I'm gonna do is quickly run it. Again, if you're in Mac, function F5. I said F5, not F4. Now I messed this up. Hold on for a second. There we go. I need to save it, and now I say function F5. And there it goes. All right. So as it's going down the list, right? The takeaway from this code is the use of range that you can see here, right? And it's highlighted on the screen. So the use of range, this functionality, right? It will tell you here's 3 parameters: 1, the 99, 1, 2, and 3, right? You got your starting point, and in what direction are you doing your movement? You can do a positive movement, so going one by adding 1 and 1 and 1, or in this case, subtracting 1. And you can subtract 2, subtract 4, or add 2, add 4, and the book was pretty clear on that. In this case, we're going from the bottles are going downwards, right? And every time we put a bottle of beer on the wall, then we have 1 less, and we keep going down the list. So this is the big point. If there's any questions of how range works, you can use Python range in Google, and it will show you how it works. Or you can use the help on the interpreter, and then get what the deal is, I think, with range or whatever functionality you're trying to use in Python. And it tells you here. See, it starts defaults to 0 if stop is omitted, right? And if you keep going down the list, it explains all the different parameters that you need to use this functionality. All right. The second takeaway of this is indentation, right? So the 4 starts here are looping. Everything is gonna execute underneath that 4 in that suite or block of code. But you can also have an indented, even deeper level of it, like incepted level of indentation, like this this comparison. If this happens, if it's true, then we're going to execute this suite. If it's not true, then we're going to execute this other suite of code. And independent of this, if the if happens or the else happens, the print will execute. Why? Because it's at the same level as this, at the first level of indentation. Does that make sense? So you can have that flow control with your indentations and your ifs, right? And just by looking at it, it's pretty clear that this code, since we're going in reverse, is checking pretty much for the last item on the list. Same thing with this other if. Checks for the last item on the list, right? If it's the last item on the list, we're going to print no more bottles. Down here, if it's the last item, but it's not bottles anymore, it's just bottle with no S, right? And pretty much that code executes all the way to the end.
I have a question actually about that. Right. Where it says if and else, does it matter the order that's put in? Like, could what's in the else section be in the if section and vice versa?
It could, depends on the logic that you're trying to apply, right? So in this case, we have only one condition is, are we at the end of it, right? If we are, I'm just gonna put that there's no more bottles, and the subtraction that I have here under the else, I don't need it, right? I don't need to subtract any more bottles because I'm done with the bottles. Does that make sense? But if you put it the opposite way, then that might mess up your logic, right? Because first of all, there's no condition here under the else, right? It's just one condition, if. Does that make sense more or less? Yeah, yes. And I guess your question, it would be even better if we have a lot of else elifs or elifs, right? When you have all these conditions one under the other. In that case, the order of the conditions might not be that important. But in this case, we only have one condition, right? And either this happens, and if it doesn't, then we're going to execute this suite of code no matter what. And this condition right here is dependent on your logic of your code. And the logic here is, I want to check if I'm done with my bottles, if I'm, you know, at the end of the list. Does that make sense, more or less?
Yeah, and I think Troy raises a good point in the chat if anyone else wanted to look at that too.
Yeah, yeah. Oh, absolutely. And yeah, since I have two screens now, I can look at the chat. Yeah. So this comparison, and this is a comparison, right? When you have the two equal signs, it says if beer number equals 1, like if it's the same value. Whereas down here, this just one equal sign is an assignment operator. You're not comparing, you're assigning. You're taking whatever's on the right and placing it on the left. In this case, the beer number, whatever that beer number we're at, obviously it's not gonna be the last one. It's gonna be, let's say 2. Then 2, we're gonna subtract 1, and then the new number is gonna be 1, right? And if it's 1, that means we're also pretty much close to be at the end. We're gonna be right here. And I don't know if you can see that. We're gonna be right here at this point. Here, 1 bottle of beer, and then print of beer on the wall. So pretty much when this line, this suite executes at the end, at this part. Does that make sense, more or less? And the way to make sense of this is you have to literally go down the code and think like the interpreter. And you know, I'm not gonna do that line by line because it's gonna take a long time, but these are good questions. Go down the line and think, okay, I start at 99. I'm gonna do just one run, so to get the example. All right, so for beer in range, so we know we start at 99, right? We're gonna stop at 0, and we're gonna go in reverse. Perfect. So beer number right now should be, you know, and we're gonna look at it up here from the, make a comparison from the top of the code. It's gonna be 99, and we see it here, 99. Perfect. Of beer on the wall, and we print that, and here it is printed. Then next line, beer number 99 of beer. So 99, the word, which is bottles on the top, of beer, and here it is printed. And then we print, take one down, pass it around, we do it here, and then it's the comparisons. All right, is beer number equal or equal 1? No, we know that beer number is what? 99, right? So this is not gonna execute. This suite of code is not gonna execute. The else. Okay, so the new number is gonna be 99 minus 1, which is 98, right? So we keep that in our back pocket. Another comparison. Is this new number 1? Are we at the end? No, we're not at the end. So we're gonna print this one, and it should be 98 word bottles of beer on the wall. And we see it here, 98 bottles of beer on the wall. Did that make sense? So that flow of execution will go, you know, 100 times. All right, perfect. Yeah, if it makes sense, always give me a 1. And it will repeat, you know, looping all the way to the end. So that's how that works. Okay. Always checking, are we at the end? Are we at the end? Just to change the word bottle to bottles. I'm sorry, the bottles to bottle, and then to make sure that you know, there are no more bottles to be printed, and that's that. So that's pretty much how the flow works, indentation works. All right. Now, what brings us today? So I added some pages to read, kind of last second, like yesterday, and the reason is because I'm still getting the feel for how many pages we can cover in 30 minutes. And hopefully this is the right amount of data to give you, okay? So we talk about variables, right? And the book told us that they're dynamically assigned. What does that mean? Dynamically assigned means that you don't have to tell the interpreter, hey, I'm gonna give you an integer inside this variable. Because other programming languages, you will have to write int and then the name of the variable whatever, and then do whatever it is you're gonna do with it. You gotta actually tell the type. Well, Python does not do that, thankfully. And let me give you a couple of examples that were not in the book, but I will just quickly show them here on the interpreter. So let's take number, the variable number, and let's give it a number. Let's give it number 1. So now we assign the value 1, the integer, and if we print it, if we print number, it's gonna be number 1, and we see it on the screen, okay? Now there's a nice functionality for Python that's called type. And type will tell me what, it's kind of self-explanatory, what object is inside number, what type of object. That's another thing. Everything in Python is an object, right? Numbers, strings, lists, everything is an object, and you can put objects inside other objects. And the book also talk a little bit about that. So type, if you hit type a number, hit enter, it will tell you the class is int, it's an integer. Does that make sense? Right, and this is pretty cool too, so you can figure out what's inside your variables, what's the type that you'll be expecting, right? We can do the same thing with a string. So let's make a variable called stringy. And let's assign it a string. Let's assign it forecast. I'm not saying that you gotta vote for me, but you should, just saying. All right, so if we put here type and we put stringy, it tells us it's a string. str stands for string. Pretty neat. Now, let me show you a couple of things here. There is a nice functionality where you can turn integers into strings, and it's called str. And let me I'm gonna print it out. str, and we're gonna take our variable that has a number, and I'm gonna apply this functionality string and then print it out. Notice I'm going from the inside, doing this first, to the outside, doing the print afterwards, which I just mentioned a second ago. Okay, so let's see what happens. Well, when it prints, it will always print as a string. Let me do it this way. Hold on, because that's kind of cheating on my part. Let me do here this way instead first. There we go. This is a better way of doing it. If I do the string straight up, here you see the one with the little parentheses, whatever. That makes it a string right there, right, like a character. Still, if I still print it, it doesn't change it though. Don't be confused, right? If I still print my number, it's still gonna be a number, right? Because that's the type. But for you to be able to change this to an actual character, or I say string, you have to then assign it. So if you do this, string number, and assign it back to number, and then you print that number, it's not a number anymore. It should, again, it should be a string. Let me do this. What am I doing wrong here? Just give me a sec. Let's Google it. We're gonna see this live.
Sorry, just so I understand.
Mm-hmm.
I don't know.
As always, I'm looking for that.
So what you're trying to do is assign a number as a string, and then to reassign it back to a number. You have
yes.
Okay, so that could be helpful. Say if you, I don't know, maybe with like phone numbers or something, and if you're doing developing a forensics tool, that means if you want to like something like a phone number, like those numbers to be associated as a string. Would that be an example?
Yeah. So sometimes the data source that you're taking the data out of will take it as a string, but it's numbers, right? So you might want to change it to an integer to then do math with it, right? If it's like a UTC timestamp, which is a big long, number 1470359x, whatever, right? When you pull it in from your file, it might pull it in as depending on what you're working with, as a string. Well, you might want to convert it to an integer to actually then do operations on it, or vice versa. Maybe you want to send it to a report, and you want to put that number as part of a string. So sometimes it's easier just to change it to a string and then print out everything together. All right. So that's why. Let me see my examples here because I wrote it down. Well, we'll deal with that later because I don't want to waste time on that. But what's happening right now is I was expecting a bracket here. So I don't know why I'm not getting the bracket. So it's my fault, but we'll figure that out later because this is not really the important part I want to talk about. But the point is this: you can change the variables are dynamically assigned, and they know the type they are, right? And why I'm not getting the bracket here, I will figure it out later. So I'll put that on the Discord because it's my fault. All right. So with that being said, the next big topic that the book talks about is the 4 main data structures, which are lists, dictionaries, tuples, and one that I always forget because the tuples and what's the other one? I never use it. Tuples. Well, I mean, I shouldn't say that, but I rarely use it. List, tuple, dictionary, and set. There we go. List, tuple, dictionary, and set. There we go. The sets I use a lot. Lists I use a lot. Dictionaries I use a lot. Tuples I don't use a lot. So let's give a quick example of each. List we're already familiar with. And I'm going to open the little piece of code at the end of the pages for today, which is vowels. And a list is defined with the brackets and the items separated by a comma. Okay. Now you can make a list, and this is part of page pretty much at the end, page 54, 55. And for those that have the Python, not Python, the Kindle version is the page that starts with creating lists literally, pretty much the last page of this we're discussing today. And I'm gonna give two examples of this. So we're gonna make a list called sample, and we're gonna assign to it a number. We're gonna then assign to it a string. Then we're gonna assign to it another number. And then we're gonna assign it another string. Let's do forecast again, because why not? Okay, this is my list. And to apply what we learned a second ago, let's see type and see what happens. It tells me it's what? A list. And this is really useful too. I found myself when I'm like, why am I able to access this list? And it's not a list. It might be something else. It's another type of object, right? So this type really helps you to kind of keep track of what the variables have inside of them. All right, so this is a list. This is fantastic. How do we get stuff out of a list? The first concept you need to understand is that lists are also called arrays, and they can be accessed by the address of each member of the list. And what's the address of the list? Imagine that each member of this list is in a little house, has their own little house, and the house numbers go from 0 to incrementally to the end. So number 1, the house number is 0. This string, the house number is 1. This string, the house number is 2. And this string, the house number is 3. How does that look? If I go print and print sample, the brackets from my list, and put 0, I get the value 1, which is inside address 0 for that array or that list. Does that make sense? Does that make sense? If it makes sense, give me a 1. All right, awesome. All right. Now, one more. Print sample, and let's give it a 1. And we should expect to see DFIR. How we get DFIR? Oh, that's why. You know what happens with here? I'm looking at this. It's me being a dummy. Since I'm printing, it doesn't. It will take the brackets out when you use the print functionality, because here it also took it out because it's a string. It doesn't need to tell you it's a string with the brackets. So this was correct. This is a string. Not here, but here. This is a string. Anyways, all right. So and so forth. So you can access them by location. An example of forensics functionality, and I'll show you in a second. When you run a query, a SQLite query, and you get the results from a query of a table, maybe the table has, let's say, 20 fields, and you might not want all 20 fields. Maybe you want field 1, field 5, field 10. Well, take your results, put them in a list, and then just call out which ones you want, right? So it's one way that I've used it, and I'll show you that in a second. All right. Other teaching point, again, you can mix types. This is an integer, this is a string, and this is a float. And a float is a fraction, right? 3 point whatever it is. So floats are fractions. You can also have floats on mixed within lists. Okay. What about next file structure dictionaries? I'm not gonna type it, but I'm gonna show you one. The heart of some of my scripts, at least the one that deals with Androids and iOS, is this script. And I have this is a, hopefully you can see it. Hopefully it's not too small. If it's okay, give me a 1 if you can read it. Okay, good. So the way you define a dictionary is with curly braces like that, right? Hopefully that's what it's called. Remember, these ones over here are for lists. What's the name of it? Brooke, what's the name of this? Or anybody? I forgot. Bracket? It's a bracket, right?
Bracket.
Yeah, bracket, right. So brackets define, hey, you can have, by the way, I should say this, sample 2. You can have empty lists just by doing this. You see that? And that's an empty list, right? If I just print out the list straight up, I get as nothing, right? And actually, since I'm printing the whole thing out, why not print sample as well, right? Right, so you see that? So, and you can have empty lists, but the bracket defines the empty list. What a dictionary is defined by the curly braces. okay? And you will have a key, colon here, and then a value. In this case, this value is really long. It's like in parentheses. And don't worry about what's inside here right now, but just think of this, of a dictionary as having keys and values, all right? Really important. Lists are ordered, right? The way you put them in, that's the way they're gonna show up. Dictionaries, you put stuff in a dictionary and it has no order. If you wanna get to something, you need to call it out by the key, which by definition tells you that there cannot be repeated keys, right? Because if there's two keys that are the same, how will you call something out, right? I mean, it doesn't allow you to do that. Keys have to be unique in Python dictionaries. If you don't do that, it will complain and it's not gonna work, okay? All right. So next data structure, and I'll give you examples how that works, is the set. So the set is on order, but no duplicates allowed at all. And I can give you a good example of it, or some code that uses it, which I will do in a second. And which one am I missing? I think it's the tuple that I'm missing. Since I barely use it, let me just quickly remind myself. Yeah, right. So yeah, the tuple is a list of objects that doesn't change. If you make a tuple, you cannot add or delete anything from it. And that's why I don't use it that much. But surely there are implementations where you need some data to never change, then you put in a tuple or tuple. I don't know if I'm pronouncing it correctly. T-U-P-L-E. All right. So we discussed that. So how can we give you some examples of how does that work?
Quick question.
Go ahead.
If I may interrupt, sorry. Quick question.
No, absolutely.
Somebody might have answered it actually already in the chat. Are dictionaries indexed the same as lists?
A great question. Great question. And I haven't looked at what the answer is, but the answer should be no. You cannot access a dictionary by their house address, like I call it, their index. You can't. It's by the key value. That's how you get to them. Because it will tell you. It will complain. It will say that you cannot. It's expecting something else, and it will give you an error. Is that what somebody else said on the chat?
Mm-hmm.
Okay. Yeah. Yes, you would. Well, yes. I mean, if you're calling a specific key to get a specific value, you have to be specific, of course. But you can also do a search in that dictionary, and we'll show that down the line with the book. Or you can iterate like we did with a list with fors and all that. And there's ways of iterating only by keys, iterating only by values. There's a way of iterating by having the key and the values being pulled out at the same time as you're going through the dictionary, which I use extensively. And you will use it extensively too for dealing with BP lists, dealing with possibly maybe even XMLs, dealing with protobuf. Specifically, you might use it a lot with JSON. Remember, JSON, if you're not familiar, look it up. JSON is nothing more than a collection of keys and values. That's it, which is precisely what a dictionary is. Can it get complicated pretty quickly? Yes, because you can have a key and a value, and inside that value, which is the example I have on my own code, in this parentheses is the value, right? But that value inside of it has additional, values in it, and you might have a key with another value in it, right? You cannot what's what I'm looking for, like nested there, right? And there's libraries that help with that, so don't be like discouraged. There's libraries that will help you deal with that, and we'll get to them down the road. But what you need to know now is dictionaries are super useful. In my script for iOS and Apple and Android parsing, this dictionary to search gives me here the key for the artifact that I'm gonna be working on, and then the value is the artifact name, and where am I gonna find that artifact in my data source. And that's how I keep track of my processing in my script, by using a dictionary. Key, what the artifact is, value, name, and where do I find it. And I feed this information to my other scripts to go and get that data from me and then do processing. Did that example help on how a dictionary might be used? If so, give me a 1. If not, give me a 0. And there's no shame if you give me a 0, because that means I need to do better. Okay, good. Now, and again, this is, okay, so we got that. Now, an example of using the other file structures. I have a script here called UIDIS. I don't know, I'm really bad at naming things. So, and what the script does is it does the unit intersection difference and symmetric difference of 2 text files. Why is this useful? Let's say you have one big log of IPs, right? And you have another big log of IPs. and you want to get the unique IPs from both. Then what you do is you run the script and select union, right? A set that contains all items from both sets, duplicators are excluded. Well, that's easy, right? If you're using a set and we set a set is unique objects, that makes super easy. Just put everything on a set and that's it. You're done, right? And I go and applying, sets in different ways here, right? For example, difference. Return a set that contains the items that only exist in X, but not in Y. And this is really useful. I found out from a couple of different folks involved in discovery, which is a space I'm not really familiar with. I'm more familiar with the law enforcement sector. And they told me they found it super useful when they have text files and need to exclude or combine things. And let me show you the code real quick. It's literally a set. That's all. Sets used in different ways. So here it is. So I define a set and I put my stuff in the set. I don't know if you can see it there, hopefully line 44. And that's my set. That's it. Super easy. And then I do different things with the data. I manipulate it in different ways to get the intersections and all that. But the point is that you can use sets for these purposes. You can use dictionaries. You can use lists. Data structures are at the heart of what we do as forensicators by at parsing data, or at limiting the amount of data we need to look at, or at getting unique sets of data. It's at the heart of it. Okay? I'm looking at my notes, see if I'm missing anything. I think I'm almost done here. Set using lists, I give an example. All right, so the last part, two last things, is the last example of code, which is the vowel little script. So let's open it. The vowels. All right, perfect. I'm gonna just run it real quick. F5. So what's happening here? Here we defined a list, and we know that because of the brackets with an ordered set of items. And we define a variable called milliways, and this is a string, right? So see how you know what the verbiage you need to use, you know how to interpret things. Now we're gonna use our looping or control flow functionality here. So for letter in word, right? So we're gonna look for this variable letter in word. If letter, right, which is the first in the first iteration, right, the first one. If A is in vowels, print that letter, right? And then goes around. If E, print that letter. If I, print that letter, and it kind of goes through it. Obviously, it's going through the word milliways, so it's gonna go, one by one, one by one, one by one, right? So the first iteration, the first letter is M. If M is in vowels, well, it's not, so it's not gonna print it. Is I in vowels? Yes, so there's the first I on the left. Then goes through L, nope, nope. Is I in vowels? Yes, prints the I. Then W, nope. A, yes. And then Y and S, no. Does that make sense? It's like a quick, again, think like the interpreter, all right? You're looking for letter by letter to check if they are inside of our list. And if they are, they print it out here. Did that make sense? Give me a 1 if it makes sense. If not, give me a 0 and I'll try to do better.
We have a 0.
Right, it's a cap sensitive? That's a good question, right? And you know what? I'm not gonna answer it. We're just gonna do it. So I put a cap there. So let's see what happens, right? Let's experiment. So let me save it and let's run it. What's the answer? Yep, it is. Yes, it is, exactly, right? So because we're looking for the precise character, and again, I haven't said this enough. If you have one letter with the brackets, it's a character. If you have more than one, it's a string, all right?
How did you declare a letter? And somebody else asked, so is letter a predefined list in Python?
That's an excellent question. Love it. The answer is no. I mean, check this out. If I put X here, and I put X here, and I put X here, that's a great question. Love it. It's still gonna work. It's just a variable name. All right. And I'm gonna go into that in a second. Yeah, capitalize different ASCII value on lowercase I, and Jason is absolutely correct, right? It's different characters, right? So the Python will look for that character. For us visually, we know that an I, is it capital or not capital? Now, is there ways of dealing with that? Yes. There's built-in functions in Python that you can put your letters, it would turn them into uppercase, all of them, turn them all into lowercase, make some analysis independent of the case. So there's functionality for that you can use, and we might get into it later. But as is right now, that's how it works. How does the matching? Yeah, so the X here is just a variable. I mean, you can name it whatever you want, just a variable. For whatever, it's a placeholder for that looking into the vowels. Looking into the contents of word to see if it matches a vowel that we have defined in our list. Hopefully that answered the question. So I see here in the chat that X or letter is a variable that we're declaring. Yeah, we're declaring it here because we'll be assigning each letter to that variable, right? In here. If we don't do that, and that assignment is transparent to you, right? By using the word in behind the scenes, it's saying, okay, it's X, right? In Word, and then it takes the first letter of Word and puts it in the X to do that, to do the comparison here. That happens behind the scene. You don't have to type it yourself, okay? Which makes it really easy to, I mean, to me, it's super nice because I say, hey, is this in this? I don't have to think about moving the content into the variable and then look into it. It does it for me in a sense by using the ins. And that in is again, it has its color on it. So it's a defined word, reserved word in Python. My question is, how did I know to match X to the vowels? That's done in the if. I think somebody said it too. But yeah, so the for here, what the for does is, all right, it's the looping mechanism. So it's gonna take, okay, behind the scenes, it's gonna say, okay, we're gonna deal with this amount of data, which is here, the word one, all right? And for whatever comes next, right, the first item on that string, we're gonna then do something with it. What are we gonna do? We're gonna check if that M, if you do in the first go around, if that M is in vowels, and then it checks the list to see if it's there. And if it's there, it prints it out, right? And then when it goes to the next loop, then internally, you don't see this, but it's because of the for and the in, then it goes to I, right? Is I in Word? Yes. The question is, I'm sorry, I said it wrong. For X in Word. So then we go now to the next I, the next letter. Done. Now is the comparison, my bad. Now, is I in vowels? And then it goes and prints it out. And again, sorry for, sometimes I trip myself up when I'm talking, but hopefully that makes sense. Here you control the movement one by one by one by one of the items in that variable. Before we used range. We used range, and in range we defined how far we needed to go, either forward, right, from 0 to 10 or 0 to 5, or backwards, like the beer song, from 99 to 0. So we define where the start and stopping points are. Here on R4, when we use in, Python internally knows that it's gonna go through the contents of Word till the end. I don't have to define that. It will just go through it on its own. It knows that, okay? Jesse is making a great point there. Yeah, the first loop X equals M, the second loop equals I, and it goes down the list letter by letter by letter. And Python knows where to stop based on the contents of Word and using the in functionality here. It's all built in, which is fantastic. Yeah, Python is great. I love Python. I love that it makes coding super simple and is cross-platform. And you're saying this is not simple at all, and I get it, but we'll keep building. And at the end of the road, you'll be like, oh, this is fantastic. I love it. In my head, I read it as for each item in Word. Yeah, that's a good way of being the interpreter in your head. I like that. Somebody said, let's do Java. Okay, you're kicked out of the group. Like, out. Security. Who said it? Oh, this is moving too quick. Yeah, whoever said, let's do Java, get out. I don't want you anymore here. All right. Yeah, so Jesse just gave us a comprehension, but we're not gonna get into that right now. You're being a smart dude. All right, so all right. So I think that's, oh, I lied. One last thing. I went over the 30 minutes. I apologize. One little last thing. Let me give you an example, a deeper example of this stuff. Because there's no point if you don't see it as applied to something that you might do in your casework. So this is an artifact that I have in my own scripting. This one here is again a SQLite query, and in mobile we do a lot of SQLite queries. And as we progress, I'll show you more complex file structures. So the only thing you need to worry about here is a couple of things. The first one is we do our query here, and that's great. We have our query, and this is the part I want you to, and then we execute the query. You know, here execute that long string of command, or not command, but I should say of SQL you know, instructions. Okay, now here this line, and you don't have to worry about knowing what it means. We'll get to that down the road. But here it takes the results of that query, right? And then here I check if the query had results. And actually, I want to show that to you. This is a good functionality. I should have told you before. If you use length, means the length, how long or how many items are inside, for example, your object. I already deleted sample. Let me use, oh, sample is empty. So that's not defined. Yeah. So let's use sample. Oh, I think it went away. All right. So let's define it real quick again. Sample. My bad.
I'm just going to interrupt here because I know
yeah, go ahead.
We're a little bit past the formal class time. If you're okay with us continuing to go on, can you just put 1?
Thank you so much, bro. That's good. I get so wrapped up on it.
Okay.
And literally it'll take like 3 more minutes.
And if you're not and still have lingering questions, just shoot me a private chat or put in the Discord, and we'll get to you later.
Yeah. Thank you, Brooke. For you're the sane brain in this operation. All right. And there we go here. There we go. That's what I should have done. Okay, so I define a list. When I use length for length, it tells me, okay, inside that list, we have 4 items going from 0 to 3, right? But 4 items, 1, 2, 3, 4. Does that make sense? So going back to my script, I run my query and I check if the rows that I got from the query, I take that number and then I check, is it more than 0? Because if I do a query and I have 0 rows, what does that mean? That means that the query didn't select anything. There was nothing to select. The conditionals that I put didn't give me any results. In that case, then, okay, there's nothing there that I care about. I'm gonna go down and say, oh, look, I have no call data available. I'm done, and close the database and I leave. But assuming I have data here in my if, then I'm gonna do certain operations. And I wanna show you here that I have a for, and this for, what it does is it goes through the results I get from the query, goes line by line and goes by line, checking the contents of call type using if, elif, and else. That's what I want to show you. So you see on the script, I query the call log database. Then I check if I have results. If I have results, I check certain values that I care about with an if, and then you know, it's part of my processing. The next part is I use a list, and we'll talk about this in next class. I take the items that I cared about from the results and I put them in a list, right? And then I take that list and I make a report with it down the road at another point. But notice here how I'm using, you know, the notation here by, remember the row 1, row 0, row 2, and I select the fields that I want from my query this way. All right. One more thing I want to show you. Notice here in my script at the beginning in line 4, then from this library or module, I'm importing 2 functions, logfunc and tsv. I want to focus on tsv because when we talk about imports, it's hard to visualize it, and I didn't cover that last time, so I want to visualize that for you. The moment I import from this script or this library or module, this function means that I can later go and call it, which I do down here, right? And where does this function live or reside? Because again, there's no TSV definition here. Well, I said it's on ilab funcs. So if I go to that module, you'll see it defined right here. Does that make sense? So I take the code from somewhere else and I import it into my script so I can use it, call it, and use it. And this little piece of code, I'm not gonna go into details, but what it does is it takes your the results of the query and turns them into a tab delimited file that you can then import in other tools, Excel or whatever you want, right? But I just want to show you those 2 things of how it's used in the real world. How do you use your list? How do you use your if and else's? How do you use your fors? Okay. And lastly, I said last class that I'm gonna show you how to use an F string in the real world. So this is the example. In Androids, the auth tokens data, it's defined by user, and Android is multi-user, right? So what I do is I take the user ID that I'm working with, and I use an F string when I do my report. So auth tokens for user 0, there you go. And then auth tokens for user 11 or 3 or 2, whatever, it goes there. So, you know, I use the F string to be able to access my variable values within a string, like I discussed previously. This is one example of how I actually use it. Okay. Yes, a good point. If you don't have a Python 3.6, F string is not gonna work. So it's gonna be higher. I'm working with Python 3.8 something. So where's my terminal? There we go. So I'm working with 3.8.3, which I believe is the latest version, if I'm not mistaken. All right, so just keep that into account. Is that a typo where I put all tokens? I bet. It could most likely. I typed it, so I bet it's a typo in there somewhere. On line 50. Well, anyways, let's stop the recording at this point. I think we're done with the part that we're gonna cover today. So let me stop the recording, and I'll put the what pages are we covering. I'll put them again on Discord. I think I did, but I'll do it again. Right. Start recording.